Okay, I did not feel good about how I left my explanation Friday. So I want to go back and revisit a couple of things because I think it's important that you understand where the math is coming from. Because with a lot of trigonometry, there's a lot of things that can be explained in multiple ways. And there's a whole lot of different connections that you can use. And it's sometimes hard to try to focus on just one way and instead of kind of going off and doing one problem one way and one problem a different way. There's a lot of different ways that we could go about doing these. I do want to mention though that your homework is asking you to do this without a calculator. On your test, you will have to do it without a calculator. So practice on your homework without a calculator. So be sure that you know how to do that. That's going to become also useful for you when you go on to calculus. Now, we're going to be looking at these two reference sheets here. And you're going to be allowed these reference sheets on your test. So be sure that you know how to use these. My examples that I'm going to start off with today are not on a handout, I don't think. I mean, I may accidentally do the same numbers because there's not a lot of numbers to choose from. Color code things. Here's the highlighters out. I'm going to look at finding the cosine of 300 degrees. Let me take it back up. There's a step-by-step thing in your handout on how to do this. I'm not using those steps right now because those steps are sort of by shortcut. And I want to figure out where that shortcut is coming from. I think I left that. All right, I'm going to draw in an angle that's 300 degrees. I know that this is 180, right? These go by 90, 90, 180, 270, all the way around would be 360. So I know 300 is over here in quadrant 4. By what I've learned so far, I know that if I can find a point on this terminal axis, right? This is all the way around here. If I can find a point here on this terminal side of this angle, not terminal axis, but on terminal side of the angle, then I can use my circular definitions. Now I know that if all the way around here that I have marked as 300, I know that this angle in here is 60 degrees. That is what I'm calling my reference angle. The angle that's made by the terminal side and your x-axis is always going to be your reference angle. Right? So if you're over here in quadrant 2, this is your reference angle. If you're over here in quadrant 3, then this is your reference angle. It's made by the terminal side and your x-axis. That's not straight at all. Pretend that's straight. Right. I know that if I were to draw in this perpendicular line here, and I'm just looking at that right triangle, I know that I can find sine, cosine, and tangent of a 60-degree angle. And I can use this chart to do it. Right? I know that it's also over here. I know those are the ratios. You can actually go back to this if you want to, but we're going to save ourselves a little bit of time and just go to this. So this 60-degree angle here is going to have the cosine of 1/2. I know the ratios here based on this information. The side that is adjacent to the 60-degree angle is 1. And the side that is opposite the 60-degree angle is the square root of 3. And this distance from the origin to this point P, what we've been calling R, if I'm looking at this as a right triangle, that's the hypotenuse, that's going to be 2. If I look at this 60-degree angle and say, okay, the cosine is adjacent over hypotenuse, it would be 1/2. Does that make sense? But I want to somehow relate this cosine of 60 degrees to the cosine of 300. That's really what I want. Let's look at this point here, XY. This X coordinate for this point is 1. The Y coordinate for this point would be negative square root of 3. So now I know a point that's on this terminal side of the angle that I'm looking for, 360 degrees. So now I can find sine and cosine tangent of 300 degrees. Remember that cosine of theta, according to our circular definitions, is X over R. So the cosine of 300 degrees is going to be 1/2. It is the same as the cosine of 60. And let's stop and think about why that is. Well, the cosine of this angle here, 60 degrees, is going to be a positive number because I'm just looking at it in a right triangle format. But when I'm looking at it in a circular definition, my cosine is based on X and R. R is always positive. And when I'm down here in quadrant 4, my X value is positive. Does that make sense? If I'm in quadrant 4, this X coordinate is positive. So my cosine of 300 degrees is going to be the same as the cosine of 60 degrees because my X value is positive. Right? I'm positive in quadrant 4. What about my sine of 300? That was cosine, but what if I wanted to find the sine value of 300? Well, I can do all of this same stuff here. And my sine value now is sine. Sine of theta is y over r. When I'm in quadrant 4, my y value is negative in quadrant 4. So in this case, I have the sine of 300 degrees is negative the square root of 3 over 2. It is the same as the sine of 60 degrees, or pi over 3, except that I have a negative here. So what I was trying to tell y'all Friday about each little step, doing it this way, should make sense, right? I can fill in the sides of this triangle. I can then figure out what X and Y are. And then I can go back to my definitions of X over Y and Y over R. Or I can use my exact value chart to figure out what that sine or cosine or tangent is going to be. And then from there, to figure out whether it's positive or negative. What the shortcut is to know that I don't really need to write down this point. I know that my trig function of the reference angle and the trig function of the angle I'm looking at are going to have the same values, except for maybe a negative sign stuck up front of it. So that's what I have to do, is to figure out whether my answer is supposed to be positive or negative, and then figure out the trig function of my reference angle. And that's actually where that step-by-step paper came in the other day. I don't think I have a copy of it with me. Where, if your first step was to sketch your graph, and then the second step was to determine your reference angle, and then figure out whether your sine, cosine, tangent, or whatever it is you're looking for is supposed to be equal to or the opposite of the angle that you're given. Let's see here. I think we had done a couple of problems with the stuff that was on your handout. I want to go on to problem 13, where we are. Problem 13. I have sine of 5 pi over 3. My first step is going to be to sketch that angle. I know this is pi. I could also write it as 3/3 pi. So you need to know where 5/3 pi or 5 pi over 3 is going to land. You can think of this as 2 pi, or you could think of it as 6 pi over 3, right? Because 6 divided by 3 is 2. Right, 1/3 up in here, 1/3, 2/3, 3/3, 4/3, 5/3. So 5/3 pi is going to be down here in quadrant 4. So there's my angle that I'm given. That's my first step, is to sketch the angle. My second step is to figure out the reference angle. And again, the reference angle is always made by the terminal side of the angle that you're given and your x-axis. So if you were to pick a point on your terminal side, and then make a perpendicular line to the x-axis. In this case, I would be going up to the x-axis, right? If you're over here, you would be going down. So what is this angle in here that I've got marked as pink? What's the measure of that angle? If this is 5 pi over 3, all the way around 6 pi over 3, what's that pink angle? Pi over 3. Okay. Anybody have any questions on how I've got that angle? Now I'm looking for the sine value of that angle. The sine of theta is y over r. If I'm down here in quadrant 4, is my sine value going to be positive or negative? Well, what's my y value down there? Negative. So my sine value is going to be negative. Does that make sense? Because r is always positive. So what determines this is just the y, right? Y is negative in quadrant 4. So my sine value is going to be negative. So the sine of 5 pi over 3 is going to be the negative of sine of pi over 3. In other words, I'm going to find the sine of pi over 3 and stick a negative in front of it. So the sine of pi over 3, square root of 3 over 2, and I just need to make that negative. So negative square root of 3 over 2. So on this problem, I really didn't go back to a specific point on the line. I didn't really label all of my triangle. I skipped a couple of steps in there. This is my shortcut. This reference angle of 5 pi over 3 is either going to be equal to the reference angle that I'm given or the negative of the sine of the reference angle. So let's look at problem 14. I have the cotangent 13 pi over 6. So first step is to sketch this. This is pi. This is 2 pi, and I know that I can also write that as 12 pi over 6. So 12 divided by 6 is 2. So 13 pi over 6 is actually going to be up here in quadrant 1. It's all the way around and then some more. So that was my first step to sketch the angle. What is my reference angle? What is the measure of this pink angle in here? If this is 12 pi over 6, this is 13 pi over 6, what is this going to be? Pi over 6. Any questions on how I got the reference angle of pi over 6? Okay. The cotangent of 13 pi over 6 is either going to equal the cotangent of pi over 6, or it will be the opposite. Okay. So basically, what I'm asking is, are they going to be equal? Is this okay? Or do I need to stick a negative up here? Cotangent of theta, according to this, is x over y. Well, when I'm in quadrant 1, x and y are both positive. So the cotangent of 13 pi over 6 is going to equal the cotangent of pi over 6. And you can see by looking at the picture, they lie in the same exact spot. So I just need to figure out what the cotangent of pi over 6 is. If you look at your table here, it doesn't have cotangent. It just has sine, cosine, tan. But I know that the cotangent of pi over 6 is 1 over the tan of pi over 6, or it's the reciprocal. I'm just going to take this and turn it upside down. So instead of square root of 3, it's 1 over the square root of 3. And I can do it from this as well. 1 over the square root of 3, rationalize my denominator. I get the square root of 3 over 3. Any questions with this so far? Okay. On problem 15, you are given, or you are asked to find the cosecant of negative pi over 6. All right, I want y'all to try to do that one on your own. I need to take roll while y'all are doing that. One, two, three. So you take a point on the side. straight up or straight down? This looks like it's a little bit. We're going to need to do a few more examples because I think there's some of y'all that are still really struggling with this. First step is to draw in that angle or sketch this angle, and I think everybody can do that. Right, when you're going counterclockwise, this is -pi/6. your reference angle is always going to be made by the terminal side of your angle and the x-axis. Right? So if you're down here in quadrant 4, you pick a point on your terminal side and you're going to go straight up to the x-axis. If you're over here in quadrant 3, pick a point on the terminal side and then go straight up to the x-axis. If you're in quadrant 2, pick a point on the terminal side and then you're going to go straight down to the x-axis. This reference angle here in pink and here in pink is going to have an adjacent side in this right triangle that is equal to the x coordinate of a point that's on the line, or the negative or the opposite of the x coordinate that's on the line, right, for your cosine. And then for a sine value, it's either going to be equal to the y coordinate or the opposite of the y coordinate. But either way, when you're making your reference angle, be sure that you're going up to the x-axis. You're not going over here to the y-axis. You're going to the x-axis. Okay, so sketch the graph of the given angle and determine if the trig function of the given angle is positive or negative. When you are looking at the cosecant of negative pi over 6, cosecant according to your circular definitions is r over y. If r is always positive, what's going to be my y coordinate down here in quadrant 4? Well, the y coordinate is going to be negative, right? So I know that cosecant of negative pi over 6 is going to be the negative of the reference angle. And my reference angle was pi over 6, right? This angle measure in here is pi over 6. If you look at your exact value chart, you don't have cosecant there. You have sine, cosine, and tangent. We want cosecant. Well, I know that cosecant is the inverse or the reciprocal of sine, right? So cosecant is 1 over sine. So this would be 1 over sine of pi over 6. And sine of pi over 6 is 1/2. So just turn that upside down. You get 2 over 1. And remember, you still have that negative out front. So this would be -2. There's quite a bit of steps to get to that answer. Any questions with this so far? Okay, so the next problem I want y'all to try on your own here is the tangent of negative pi over 6. I think that's 16 on your handout. Yes. Negative square root of 3 over 3. Anybody got that?